Hi folks, I just wanted to recap some of the properties of demand functions under a CES utility function. Remember a few videos back we looked at income elasticities of demand, and we found out that when the utility function is a constant elasticity of substitution, the income elasticity of substitution is always equal to 1, meaning there are no luxury goods and no necessary goods under a CES utility function. Every good is always consumed in constant proportions when you change income. So a consumer's income can double and they'll still consume the same fraction of their income on food, for example. This is a little counterfactual. We know from the data that when people get richer, they tend to consume a smaller share of their income on food and a larger share on things like vacations, for example. But it's still very tractable. So this is one of the reasons why we use the CES utility function. We can also think about the properties of relative demand. So I've written up here in the top left the relative demand function. I've simplified it a little bit from what we saw. So the weights, the alphas that we had in the previous video, I've just assumed they're equal to 1. And the relative demand of good 1 relative to good 2 is just this function of the price of good 1 relative to that of good 2. And clearly, the shape of this demand curve, this relative demand curve, is going to depend very heavily on sigma, which is, again, the elasticity of substitution between the various goods. On the right here, I've drawn this relative demand curve for various different sigmas. When sigma equals 1, we get this nice symmetric curve, the blue curve. When sigma is greater than 1, we have a flatter curve. So for example, if sigma is 3, we get this bold green line here, which is a slightly flatter relative demand curve. And when sigma is arbitrarily large, we get this perfectly flat relative demand curve. In other words, if the price of good 1 relative to good 2 increases even slightly, I'm going to substantially reduce my consumption of good 1 relative to good 2. These two goods are perfect substitutes. They're equally valuable to me. So if one has a slightly lower price, I'm just going to buy that one instead of the one with the higher price. Conversely, if sigma is less than 1, the goods are complements. So when sigma is 1/3, we have this relatively steep demand curve in red. And when the goods are perfect complements, when sigma is 0, we get this perfectly vertical, perfectly inelastic demand curve. So no matter what the relative price is, I'm still going to consume the same relative quantities of the two goods. We can think about this in terms of elasticities as well. So if you recall the cross-price elasticity that we derived in the previous video, the cross-price elasticity of Marshallian demand for good G when the price of good K varies was given by this. Sigma minus 1 times the budget share spent on good K. So clearly, when sigma is less than 1, this is going to be negative. If the price of good K increases, I'm going to reduce my demand for good G because goods G and K are complements. So the price of good K goes up, I'll reduce my demand for good K, and because of that, I'll also reduce my demand for good G, because the two are complements. Conversely, when sigma is greater than 1, when the two goods are substitutes, we get what perhaps you might expect. If price of good K increases, the demand for good G decreases. Now, sigma also affects the own price elasticity. Remember, the own price elasticity of Marshallian demand was given by the following function. And one thing to note here is that if there are very many goods, then the share of income spent on any one good is going to be relatively small. So this pi g is going to be small when there are many goods. And so very often in macroeconomic models, you'll see an assumption stated that there are very many goods, so we're going to assume that the own price elasticity is actually just equal to minus sigma. So clearly then, if the different goods are all complements under a CES utility function, that's also going to mean that the own price elasticity of demand of any one good is also going to be relatively inelastic, because this epsilon GG is going to be less than 1 in absolute value. Conversely, if sigma is greater than 1, if the different goods are all substitutes, that's also going to mean that the own price elasticity is very elastic. So if the price of good G goes up, the demand for good G will go down quite substantially. Thanks very much, and I'll see you in the next video.